Imagine standing on a quiet beach, watching the sun dip below the horizon, casting vibrant hues across the sky. In that moment, you might feel a twinge of awe, a whisper of something greater that lies beyond our tiny blue planet. Now, expand that feeling to encompass the entire cosmos. Space is not just a void, it is an infinite expanse filled with mystery, potential, and the echoes of our most profound questions. Why are we here? Are we alone? What lies beyond the stars? This insatiable yearning to explore beyond our earthly confines is as old as humanity itself. It stirs within us a sense of adventure, a desire to push boundaries, and a quest for knowledge that knows no limits. From the first time we gazed up at the night sky, humanity has been captivated by the twinkling stars, each one a distant sun heralding the potential of entire worlds waiting to be discovered. Our ancestors looked up and saw divine beings, omens, and navigational guides. Fast forward through millennia of evolution and scientific progress, and we now possess tools that allow us to map the cosmos with unprecedented precision. Telescopes, satellites, and spaceships have transformed our understanding of the universe, revealing that we live in a vast and complex tapestry of galaxies, nebulae, and cosmic phenomena. But with this knowledge comes a realization: our small planet is but a speck in this grand expanse, and the universe beckons us to venture forth. The cosmic dawn is not merely a term for a time period, it encapsulates the awakening of human consciousness to the possibilities that lie beyond our atmosphere. As we stand on the precipice of a new era, we are confronted with the tantalizing prospect of colonizing other worlds, journeying to places once considered the realm of science fiction. This is not just a dream of the future, it's a necessity for our survival and evolution as a species. The Earth, with all its beauty and resources, faces challenges that threaten our existence: climate change, overpopulation, and dwindling resources. As we look to the stars, we recognize that our future may depend on our ability to become a multiplanetary species. What would it take to inhabit another world? Can we truly transform barren landscapes into thriving ecosystems? These questions propel the field of space colonization forward, urging scientists, engineers, and dreamers to envision a future where humans can thrive beyond Earth. The desire to explore is woven into the fabric of our nature. It drives innovation and fuels our quest for technology that can withstand the harsh realities of outer space. From developing life support systems to creating habitats that can sustain human life far from our home planet, the challenges are immense, but so too are the rewards. As we venture into this cosmic narrative, we must also acknowledge the profound emotions intertwined with exploration. Every mission launched into the abyss is a testament to human resilience, ingenuity, and the unyielding spirit of curiosity. The Apollo missions, which carried astronauts to the moon, ignited a passion for space that still burns brightly today. Those pioneers took bold steps across the lunar surface, leaving footprints where none had walked before, and their stories continue to inspire generations. They proved that the boundaries of our existence are not set in stone, we can reach for the unimaginable. Looking outward, the moon serves as our closest neighbor and a starting point for further exploration. It stands as a reminder of what we can achieve when we unite our efforts and share knowledge. Lunar bases might one day serve as platforms for missions deeper into the solar system, paving the way for humanity's presence on Mars and beyond. The moon is just the beginning, a stepping stone to the infinite possibilities that lie ahead. Mars, often dubbed the Red Planet, looms large in our collective imagination. With its tantalizing similarities to Earth, Mars presents a unique opportunity to expand our horizons. Its surface, with vast plains, towering volcanoes, and deep canyons, beckons us to ponder the potential of a second home. The prospect of terraforming this neighboring world, creating an environment where humanity could thrive, is no longer science fiction, it is a tantalizing possibility grounded in scientific pursuit. Yet, this journey into the cosmos will not come without its challenges. The vast distances, the unpredictability of space, and the complexities of establishing sustainable life on other planets present formidable obstacles. However, history has shown that humanity's greatest achievements often emerge from our most daunting challenges. As we embrace this cosmic dawn, we are reminded that exploration is not merely an external endeavor, it is an internal one, reflecting our deepest aspirations and the relentless pursuit of our place in the universe. The infinite frontier stretches before us, filled with the promise of new worlds and new discoveries. As we gaze into the starry night, let us remember that we are part of something much larger than ourselves. The call of the cosmos is not just a distant echo, it is a siren song that urges us to take our first steps into the unknown. The journey has just begun, and the possibilities are as limitless as the universe itself. In this age of exploration, we stand on the cusp of a new chapter in human history, ready to embrace the wonders that await beyond our horizon. As we embark on this thrilling expedition from the cradle of Earth to the vastness of the cosmos, we find ourselves weaving through a tapestry of human ingenuity and ambition. Our journey through space is not merely a series of technical achievements, but a profound expression of our unyielding curiosity and desire to reach for the stars. This transition from our home planet to the celestial realms above has been punctuated by remarkable milestones, each one lighting the path toward what lies beyond. It all began in the mid-20th century, when the Cold War rivalry sparked a fervor for exploration that would change the course of history. In 1957, the Soviet Union launched Sputnik, the world's first artificial satellite. This tiny metal sphere, beeping away in the silence of space, ignited not only a technological race but also a cultural awakening. For the first time, humanity gazed up at the night sky and realized that we could leave the confines of our atmosphere. The significance of this moment cannot be overstated. It was a bold declaration that we were ready to transcend our terrestrial limitations. Then came the thrilling era of human spaceflight, marked by Yuri Gagarin's historic orbit around Earth in 1961. His journey was the first time a human being ventured into space, taking a leap that seemed unimaginable just a decade earlier. With every subsequent mission, we polished our skills, learning to navigate the complex dynamics of space travel. The Mercury, Gemini, and Apollo programs became stepping stones that fueled our ambition, culminating in the remarkable Apollo 11 mission in 1969. As Neil Armstrong took that monumental first step onto the lunar surface, he did not just represent humanity on a distant moon, he embodied our collective dreams and aspirations. The words "one small step for man, one giant leap for mankind" echoed across the globe, crystallizing the notion that the universe was now within our reach. The moon landing was a watershed moment that ushered in an era of exploration beyond our satellite. In the decades that followed, robotic missions ventured further into the solar system, unveiling the wonders of the planets. Pioneer and Voyager spacecraft embarked on voyages to explore the outer planets, sending back breathtaking images and invaluable scientific data. The celestial bodies, once mere points of light in the night sky, became real, tangible worlds filled with mysteries waiting to be unraveled. The gas giants, the icy moons, and the swirling rings of Saturn sparked a deeper understanding of the solar system and the forces that govern it. As we pushed our boundaries, the development of the Space Shuttle program in the late 20th century revolutionized space travel. This reusable spacecraft enabled a new era of accessibility, allowing astronauts to live and work in space for extended periods. The construction of the International Space Station became a symbol of international collaboration, merging the efforts of numerous countries in the pursuit of knowledge. This floating laboratory served as a testing ground for technologies that would one day support human life on other planets. Here, in microgravity, scientists have conducted experiments that broaden our understanding of biology, physics, and the very essence of life itself. Yet, even as we celebrated our achievements, the stars beckoned us further. Mars, with its intriguing similarities to Earth, emerged as the next focal point for exploration. Robotic missions like the Mars rovers Spirit, Opportunity, Curiosity, and Perseverance have tirelessly roamed the Martian surface, unraveling its geological history and searching for signs of past life. Each mission has brought us closer to answering the age-old question: are we alone in the universe? The tantalizing prospect of human missions to Mars looms on the horizon, promising to take our exploration to an entirely new level. As we stand on the threshold of this next frontier, we are reminded of the remarkable pace of technological advancement that has propelled us to this point. Innovations in materials science, propulsion techniques, and life support systems have transformed what was once the realm of science fiction into tangible reality. The dream of colonizing another planet is now being actively pursued, with private companies and space agencies collaborating to create sustainable habitats. Concepts like the Mars Base Alpha and plans for lunar outposts are no longer distant dreams but projects in development. These endeavors are underscored by the intertwined narratives of human resilience and technological ingenuity. The challenges are immense: cosmic radiation, extreme temperatures, and the vacuum of space present formidable obstacles. Yet, within these challenges lie opportunities for innovation. From advanced robotics to artificial intelligence, the tools we create not only aid us in our exploration but also redefine what it means to be human in this vast universe. With every success, we strengthen our commitment to a multiplanetary existence. The vision of a human presence not just on Mars but potentially on the moons of Jupiter and Saturn or even exoplanets beyond our solar system is exhilarating. Each step we take is a testament to our enduring spirit and an invitation to future generations to continue this journey. As we look ahead, the great leap from Earth to the stars is not just about the destinations we aim to reach, it is about the spirit of exploration that drives us. It is about the unquenchable thirst for knowledge that fuels our quest to understand the universe and our place within it. The stars, once distant and unattainable, have become beacons of possibility, illuminating the path toward a future where humanity takes its rightful place among the cosmos. Together, we are embarking on a voyage that will redefine our existence and expand the horizons of human potential. The infinite frontier awaits, and our journey has only just begun. As we stand on the precipice of this monumental transition from earthbound existence to interstellar ambition, it becomes vital to grasp the science behind colonization. Establishing human habitats on celestial bodies is not merely a dream, it is a complex mosaic of disciplines, each contributing to our understanding of what is required to thrive beyond our home planet. At the very heart of this endeavor lies a blend of biology, engineering, and environmental science, all woven together by the unyielding thread of innovation. First and foremost, we must consider the basic needs of life: air, water, food, and shelter. On Earth, these elements are abundant and accessible, yet in the harsh environments of space, they become challenges to overcome. Imagine a Martian landscape, where dust storms rage and temperatures plummet. It is here that the principles of closed-loop life support systems come into play. These systems recycle air and water, creating a sustainable environment that mimics the natural cycles we take for granted. Scientists are experimenting with advanced hydroponics and aeroponics to grow food in space, utilizing minimal resources while maximizing yield. It's a delicate balance, where every plant grown becomes a small triumph against the void. The engineering challenges are equally daunting. To build habitats that can withstand the unforgiving conditions of other worlds, we need materials that are both resilient and adaptable. This is where research into in situ resource utilization, or ISRU, becomes essential. Instead of transporting everything from Earth, we can harness local materials to construct habitats and infrastructure. On Mars, for example, the regolith, essentially Martian soil, can be utilized to create building materials, reducing the need for supply missions from Earth. Concepts like 3D printing are revolutionizing this possibility, allowing us to fabricate structures layer by layer, directly from the materials at hand. Such innovations not only make colonization feasible but also reduce the immense costs and logistical challenges of space travel. Yet technology alone cannot guarantee survival. We must also grapple with the psychological and social aspects of living in confined, isolated environments. The human spirit is resilient, but it requires connection and community to thrive. Habitats on other worlds will need to be designed with this in mind, incorporating communal spaces that foster interaction and collaboration. The experience of living in a small group far from Earth presents unique challenges, where isolation can take a toll on mental health. This calls for a careful balance of privacy and communal activity, ensuring that while individuals have their own space, they also feel part of a cohesive unit working toward a shared goal. As we shift our gaze back to Mars, the potential for human colonization becomes even clearer. The red planet, with its day and night cycle remarkably similar to Earth's, offers both challenges and opportunities. While its thin atmosphere poses a risk of radiation exposure, technological advancements in protective habitats could mitigate these dangers. Solar panels, which capture energy from the sun, could power our settlements, while advanced energy storage solutions allow us to use that energy efficiently. The development of Martian greenhouses, utilizing the sun's rays to grow crops, could pave the way for a self-sustaining colony that enhances our food security off-planet. But our ambitions do not end at Mars. The Moon, our nearest celestial neighbor, offers a tantalizing testing ground for colonization technologies and strategies. Lunar colonies could serve as a launchpad for deeper space exploration, providing a platform for scientific research and development. The Moon's low gravity allows for easier construction and experimentation, providing invaluable data that can inform our ventures further into the solar system. The establishment of lunar bases could be a vital step toward understanding how to create human habitats on more distant bodies, such as asteroids or the ice giants of the outer solar system. As we contemplate the larger cosmos, the concept of terraforming emerges as a bold, transformative solution. Imagine a future where we can alter the atmosphere of inhospitable worlds to make them more Earth-like, capable of supporting human life. While this concept may seem like science fiction, researchers are exploring the possibilities of terraforming through a combination of advanced technology and ecological understanding. By altering atmospheric conditions or introducing specific microorganisms, we could begin to create the conditions necessary for life to flourish in environments previously deemed uninhabitable. The quest to colonize space is an endeavor fraught with challenges, yet it is also rich with potential. The scientific principles underpinning this vision are not just theoretical, they are grounded in the same ingenuity and perseverance that have driven humanity's greatest achievements. By embracing a multidisciplinary approach, we can tackle the nuances of life beyond Earth. As we refine our technologies and deepen our understanding of astrobiology, our journey into the cosmos transforms from a mere aspiration into a tangible reality. In this grand undertaking, we are not just explorers, we are architects of our future. Each step we take brings us closer to a time when we will not only visit other worlds, but live and thrive on them. As we venture forth, we will embody the spirit of discovery, harnessing the profound mysteries of the universe to create new homes, new societies, and eventually, a multiplanetary civilization. The infinite frontier beckons, revealing its secrets one extraordinary breakthrough at a time, challenging us to rise to the occasion and embrace our shared cosmic destiny. Mars stands as a tantalizing beacon on the horizon of human exploration, often regarded as our next great frontier. With its reddish hue illuminating the night sky, it captures our imagination and beckons us to dream of a future beyond Earth. The allure of Mars lies not only in its proximity within our solar system but also in its striking similarities to our home planet. As we contemplate the possibility of colonization, we must recognize what makes Mars an ideal candidate for human settlement. To begin with, Mars possesses a day length remarkably similar to ours, with a rotation period just over 24 hours. Its seasons unfold in a fashion analogous to Earth's, driven by a similar axial tilt. This familiarity offers a comforting sense of rhythm for potential inhabitants. Moreover, while the Martian atmosphere is thin, composed primarily of carbon dioxide, it presents opportunities for innovation. It has the potential to be harnessed through advanced technologies, allowing us to create oxygen and fuel, essentials for sustaining life. The surface of Mars reveals a world of remarkable geological features, including the largest volcano in the solar system, Olympus Mons, and vast canyons like Valles Marineris that stretch across the planet's landscape. These majestic formations not only inspire awe but also hint at the dynamic history of Mars, which once harbored significant amounts of water. Ancient riverbeds and polar ice caps provide tantalizing clues suggesting that Mars could have supported life in its distant past. As we seek to understand whether we are alone in the universe, examining Mars is crucial in unraveling the mysteries of astrobiology, the study of life beyond Earth. However, the road to Mars is fraught with challenges that demand our ingenuity and resilience. The harsh conditions present significant hurdles for colonization. Temperatures can plunge to -100 degrees Celsius, and radiation levels are significantly higher than what we experience on Earth, posing risks to human health. The thin atmosphere provides little protection from cosmic rays and solar radiation, which means any habitat must be designed to shield its occupants from these perils. Envisioning a safe, livable environment on Mars will require cutting-edge technology and innovative engineering solutions. One of the foremost considerations in establishing a Martian home involves life support systems. We must devise methods to produce food, water, and breathable air in a sustainable manner. Hydroponics and aeroponics could play a crucial role in cultivating crops, offering nourishment to colonizers while minimizing the need for extensive resources brought from Earth. Water, potentially accessible from underground ice deposits, can be extracted and purified for consumption and agricultural use. The challenge of creating a self-sustaining ecosystem on Mars is daunting, yet the pursuit of such innovation may yield breakthroughs that transform how we live on Earth. Additionally, transportation to and from Mars remains a significant obstacle. The journey to our neighboring planet takes several months, and preparing for the complexities of interplanetary travel requires meticulous planning. The development of reusable spacecraft, such as SpaceX's Starship, is paving the way for more efficient transport. These advancements not only reduce the cost of travel but also open the door to a regular cadence of missions, essential for building a thriving Martian colony. Each successful launch brings us closer to establishing a permanent presence on Mars, igniting the possibility of exploration beyond our own planet. As we look ahead, the vision for Mars extends beyond the establishment of a self-sufficient settlement. A Martian colony could serve as a vital stepping stone toward exploring deeper into the solar system, including the ice giants of Uranus and Neptune, and even beyond. Imagine utilizing Mars as a launchpad for missions to the outer planets, harnessing its resources to facilitate further exploration. This interconnected web of celestial destinations forms the foundation for a multiplanetary society, where humanity expands its reach across the cosmos. The appeal of Mars also extends to our fundamental human spirit, the desire to explore, to push boundaries, and to seek the unknown. The prospect of colonization ignites a sense of adventure, sparking imaginations across the globe. Schools and universities are already channeling this excitement into programs that inspire the next generation of scientists, engineers, and dreamers. As we share our vision for Mars, we cultivate a collective consciousness, unifying people from all walks of life around a common goal of exploration and discovery. Yet, as we set our sights on the red planet, we must also grapple with important ethical considerations. The implications of colonizing another world extend beyond the technical and scientific challenges. We must reflect on our responsibilities as stewards of Mars and the universe. What rights should an extraterrestrial environment have? How can we ensure that our endeavors do not repeat the mistakes of the past, where exploration led to exploitation? These questions will require thoughtful dialogue and international cooperation as we embark on this journey into the cosmos. In the grand tapestry of human existence, Mars represents not just a destination but a pivotal chapter in our story. It embodies our potential to become a truly multiplanetary civilization, where exploration drives innovation and fosters a deep connection to our cosmic heritage. Each step on Martian soil will echo the dreams of generations past while laying the groundwork for a future rich with possibility. As we prepare to take our next leap into the stars, we embrace the challenges, harness the wonders, and affirm our place among the cosmic wonders of the universe. The infinite frontier awaits us, and Mars is but the beginning of our extraordinary journey. As we turn our gaze toward Mars, the next step in our journey into the cosmos, we encounter a planet both familiar and foreign. The red planet, with its rust-colored landscape and thin atmosphere, poses unique challenges but also incredible opportunities for human habitation. Building a Martian home is not merely an exercise in engineering, it is a profound endeavor that will require ingenuity, creativity, and the unyielding spirit of exploration that defines humankind. First, we must consider the very essence of life itself. On Earth, we are surrounded by a wealth of resources that sustain us. We have air to breathe, water to drink, and soil to grow food. On Mars, the situation is starkly different. The atmosphere is 95% carbon dioxide, lacking the oxygen we depend on. Temperatures can plummet to -195 degrees Fahrenheit at the poles, and dust storms can envelop the planet for months, obscuring the sun. To thrive on Mars, we must create environments that not only shelter us from these harsh conditions but also provide the essential elements for survival. Imagine constructing habitats that can withstand extreme temperatures and radiation. Engineers are already conceptualizing inflatable habitats that can be transported to Mars and then deployed to create expandable living spaces. These habitats could be made from advanced materials designed to insulate against the cold while providing a durable shield against cosmic radiation. Inside, the homes would be equipped with air filtration systems to convert carbon dioxide into breathable oxygen, perhaps utilizing plants in a closed-loop system that mimics Earth's own ecosystem. Water, the lifeblood of any colony, is another critical resource we must secure. Mars does have water, albeit mostly locked away in ice beneath its surface or in the polar ice caps. Future missions may involve drilling into the Martian soil to extract this water, using technologies that have already been developed for resource extraction here on Earth. Once harvested, this water could be filtered and purified for drinking, irrigation, and even converted into hydrogen and oxygen through electrolysis to provide additional fuel for rockets or power. As we dwell on the idea of food production, we enter an exciting realm of innovation. The challenges of farming on Mars are immense, yet human ingenuity knows no bounds. Scientists are exploring the potential of hydroponics and aeroponics, techniques that allow crops to grow without soil by using mineral nutrient solutions. By creating sustainable greenhouses under protective domes, we could cultivate crops that not only feed the colony but also help replenish the atmosphere, enhancing our chances of surviving in this alien world. The incorporation of genetically modified organisms might allow for faster growth cycles and greater resilience, making it possible to create a Martian agriculture that sustains our settlers. Energy production is crucial for any settlement. Without a reliable power source, our dreams of a thriving Martian colony would fade into the dust. Solar energy stands out as a promising option, given Mars' proximity to the Sun and its long days. Advanced solar panels could harness sunlight to provide electricity, powering everything from habitat life support systems to agricultural needs. However, we must also consider the need for energy storage solutions to ensure a steady supply during the long Martian nights, which last for about 12 hours. Additionally, nuclear power could play a vital role in providing a consistent energy source. Small modular reactors, tested and perfected on Earth, could provide the necessary energy for larger operations, such as mining or manufacturing. This brings us to another significant factor: construction and manufacturing. The ability to build on Mars will heavily rely on in situ resource utilization, or ISRU. Rather than transporting all materials from Earth, we can harness Martian regolith, the loose soil and rocks covering the surface, to create building materials. Techniques like 3D printing could allow us to create homes directly from Martian soil, significantly reducing the need to send vast amounts of construction materials from our home planet. As we dream of living on Mars, we must also consider the psychological well-being of the settlers. Human beings are inherently social creatures, and isolation in a barren landscape could lead to mental health challenges. Designing habitats that encourage community interaction, with shared spaces for recreation and companionship, will be essential. Incorporating elements from Earth, such as greenery and art, could help create a sense of normalcy and comfort amid the alien surroundings. The idea of terraforming Mars, while still theoretical, tantalizes the imagination. This grand vision involves altering the planetary environment, gradually transforming the Martian atmosphere and climate to make it more Earth-like. While such an endeavor lies far in the future, the technology and innovation we develop in the meantime will lay the foundation for such possibilities. By establishing a foothold on Mars, we not only prepare for a long-term human presence but also gather invaluable data that could inform our understanding of other planets and moons throughout the solar system. With each step toward building a Martian home, we are not merely reaching for the stars, we are redefining what it means to be human. We are leveraging technology, science, and the spirit of adventure to turn the once impossible into the possible. As we stand on the brink of this extraordinary journey, we embrace the myriad challenges that lie ahead, driven by the knowledge that building a sustainable future on Mars is not just an endeavor for survival but an expression of our deepest hopes and aspirations. The dreams of a Martian home draw closer, and with them, the promise of a new chapter in our exploration of the infinite frontier. As we lift the veil on life on Mars, we encounter a landscape both thrilling and daunting. Here, the thin atmosphere, composed primarily of carbon dioxide, offers no protection from the sun's harsh radiation and temperature extremes that can plunge below -100 degrees Celsius at night. The Martian surface is riddled with dust storms that can blanket the planet for weeks, creating a relentless challenge to any settlement. Despite these difficulties, the human spirit is unfazed. We are not just dreamers, we are innovators, and we will harness our creativity and intellect to overcome these obstacles. One of the first challenges we face is the need for adequate shelter. Martian habitats must be resilient, shielding inhabitants from radiation while providing a stable environment. Concepts such as inflatable habitats, which can be easily transported and deployed, are being explored. These structures can be lined with regolith, the Martian soil, acting as a natural radiation shield. Advanced 3D printing technologies open a world of possibilities, allowing us to construct habitats using local materials. Imagine entire neighborhoods rising from the Martian surface, built layer by layer, each home tailored for the needs of its occupants, a true testament to human ingenuity. Beyond physical shelters, the question of sustainability looms large. Water is life, and on Mars, access to this vital resource is fraught with challenges. While evidence suggests the presence of ice beneath the surface, extracting and purifying water will require advanced technologies. Innovations in ice mining and purification systems will be pivotal. We envision machines that can melt ice and filter it, providing clean water for drinking, irrigation, and even extraction of oxygen. Nutrient-rich soil is another essential element for growing food, and cultivating crops on Mars will require a symbiotic relationship between technology and biology. Hydroponic systems, utilizing nutrient solutions instead of soil, will allow us to grow food in controlled environments, potentially revolutionizing how we think about agriculture in space. The psychological impact of living on another planet cannot be overlooked. The isolation and confinement of Martian life will weigh heavily on the minds of explorers. To address this, we must create a sense of community and connection. Virtual reality might play a crucial role, offering a digital escape to Earth-like environments or enabling real-time contact with loved ones back home. Moreover, designing spaces that promote social interaction and mental well-being will be fundamental. Habitats filled with greenery and light, communal areas for gathering, and personal spaces that reflect individual identities can help support the emotional health of Martian settlers. As we adapt to Martian life, the challenge of energy production is paramount. With limited sunlight during long Martian winters and frequent dust storms, relying solely on solar power may not suffice. Nuclear energy emerges as a promising alternative. Compact nuclear reactors could provide a constant and reliable power source, enabling sustainable living conditions and the operation of essential systems. Imagine a network of energy-producing units scattered across the Martian landscape, each contributing to a grid that powers everything from life support systems to agricultural facilities. Transportation across the Martian surface will also require innovative solutions. Rovers and drones have already proven their capability in exploration, yet we will need more advanced vehicles to connect far-flung habitats and facilitate resource gathering. Concepts for autonomous vehicles capable of navigating the rugged terrain suggest a future where transportation is efficient and safe. These vehicles could even be equipped with artificial intelligence, enabling them to adapt to changing conditions and optimize routes, ensuring that resources and people reach their destinations without unnecessary risk. While we focus on colonization, we must also grapple with the potential for life on Mars, whether it be microscopic organisms lingering in the icy depths or the possibility of alien ecosystems. This drives not just our scientific inquiry but also the ethical considerations of terraforming and our responsibility toward any Martian life forms we may encounter. The delicate balance of exploration and preservation will be a defining feature of our Martian narrative, steering our actions as we tread lightly on this new world. As we design our Martian existence, the collaboration between the public and private sectors will be crucial. The enthusiasm and resources of private enterprises can accelerate innovations, exploring new technologies and approaches to challenges that may have stymied larger organizations. SpaceX, Blue Origin, and other private players are not just competing, they are part of a collective effort to make life on Mars a reality. Their advancements in reusable rocket technology and habitat development offer glimpses of a future where human life on Mars is not only feasible but thriving. Looking ahead, we recognize that life on Mars is not merely about survival. It's about creation, adaptation, and the remarkable ability of humanity to rise to challenges. Each obstacle we face is an opportunity to innovate, to push the boundaries of our understanding, and to reshape our destiny among the stars. As we journey deeper into the unknown, our aspirations remain boundless, and with every step, we draw closer to a thriving civilization, nurtured by the spirit of exploration and the promise of a new frontier. This is not just a quest for survival, it is a chance to rewrite the story of humanity, one that echoes across time and space, inviting us to dream of worlds unexplored and opportunities yet to be realized. As we gaze up at the night sky, the moon beckons us like a beacon of possibility, a celestial neighbor that has fascinated humanity for millennia. It is not merely a distant rock, it serves as a vital stepping stone in our quest for deeper space exploration. Positioned about 238,855 miles from Earth, the Moon offers a unique platform where we can build the technologies and knowledge necessary for venturing into the broader cosmos. It is a place of potential, where dreams of a multiplanetary existence can take root and flourish. The Moon's proximity to Earth makes it an ideal testing ground for the challenges of living and working in space. Here, we can simulate the conditions of distant worlds without the immense distances that come with interplanetary travel. As we embark on missions to establish a sustained human presence on the lunar surface, we can experiment with habitats, life support systems, and resource utilization in ways that will directly inform our journey to Mars and beyond. This exploration is about more than just the Moon itself, it is about the lessons we learn that can propel us forward into the unknown. Imagine a future where lunar bases thrive, equipped with innovative technologies designed for self-sufficiency. These bases could harness the Moon's abundant resources, such as water ice found in permanently shadowed craters, to generate oxygen and fuel for further exploration. This local resource utilization transforms the Moon into a launch pad, where we can refuel and resupply missions destined for deeper space. By establishing a robust lunar infrastructure, we reduce the costs and risks associated with long-distance space travel, paving the way for more ambitious journeys. The Moon also offers a unique vantage point for astronomical observations. With its lack of atmosphere and light pollution, the lunar surface presents an unparalleled opportunity to build powerful telescopes, enabling us to peer deeper into the cosmos. Such instruments could unravel the mysteries of the universe, from understanding the formation of galaxies to searching for signs of life on distant worlds. Through these observations, the Moon becomes not just a transit point but a vital participant in our quest for knowledge, expanding our understanding of the universe we inhabit. In the pursuit of lunar colonization, we are also faced with formidable challenges that must be addressed head-on. The Moon's harsh environment presents obstacles, including extreme temperature variations, radiation exposure, and the fine dust known as lunar regolith. Developing resilient technologies and sustainable habitats is essential for long-term human presence. Innovations in construction materials and life support systems will play a crucial role in overcoming these hurdles, allowing us to create safe and comfortable living spaces for our future lunar settlers. As we delve deeper into the intricacies of lunar colonization, it is essential to consider the ethics of our endeavors. Establishing a presence on the Moon raises questions about stewardship and responsibility. We must approach this new frontier with a mindset of preservation, ensuring that we respect the Moon's geological and potential cultural significance. This is not merely about exploration, it is about forging a legacy that honors both our past and the future we wish to create. The lessons learned from our lunar ventures will serve as a blueprint for future colonization efforts on Mars and beyond. Each mission, each experiment, and each challenge faced will refine our understanding of what it means to live beyond Earth. The Moon's role as a proving ground is crucial. It allows us to test our technologies and adapt our strategies in a controlled environment. This iterative process will enhance our capabilities, ensuring that when we eventually set our sights on Mars, we do so equipped with the knowledge and experience necessary to thrive. The collaboration between nations and private entities will be pivotal in making lunar exploration a reality. As we unite in our efforts, we tap into a wealth of resources, ideas, and innovations that can accelerate our progress. The Moon could become a hub of international cooperation, fostering partnerships that bridge cultural and political divides. In this spirit of collaboration, we can collectively build a future that benefits all of humanity, expanding our reach into the cosmos while sharing the spoils of discovery. The Moon, with its haunting beauty and profound significance, is more than just a celestial object. It is a gateway to understanding our place in the universe and preparing for the adventures that lie ahead. As we set our sights on permanent lunar habitation, we unlock the door to a future filled with boundless possibilities. Here, we are not only learning how to survive in the harshness of space but also how to thrive as a species, united by a common goal of exploration and understanding. In this pursuit, we are not merely venturing into the void, we are embarking on an odyssey that redefines what it means to be human. With each mission to the Moon, we write a new chapter in the story of our species, a tale of courage, curiosity, and the unyielding spirit of exploration that drives us toward the infinite frontier. The Moon stands before us, waiting to be explored, its secrets ready to be unveiled, reminding us that our journey has only just begun. As we set our sights toward the moon, it becomes clear that this celestial body is not merely a destination but a vital stepping stone in our quest to colonize the cosmos. The concept of lunar colonies represents a blueprint for future extraterrestrial habitats, an experimental ground where we can test the limits of our technology, adaptability, and spirit. The moon's unique environment offers both challenges and opportunities, presenting us with a chance to learn how to build sustainable human habitats beyond our home planet. Imagine stepping onto the lunar surface, where every step kicks up a fine layer of dust, a remnant of ancient cosmic history. The moon's lack of atmosphere means that every structure we build must withstand extreme temperatures and relentless radiation. Yet, this harsh environment also pushes us to innovate, prompting the development of advanced materials and technologies that will be essential for future colonies on more distant planets. Establishing a lunar colony would require us to utilize local resources, a concept known as in situ resource utilization. Lunar regolith, the moon's soil, contains valuable elements like oxygen and hydrogen, which can be extracted to create water and breathable air. This practice not only reduces the need to transport supplies from Earth but also teaches us how to live off the land, a skill that will be crucial on planets like Mars, where similar techniques will be necessary to establish a self-sufficient community. Lunar colonies could serve as proving grounds for life support systems and habitat designs that prioritize sustainability. Envision greenhouses nestled within protective domes, where crops could thrive under carefully controlled conditions. These agricultural innovations would not only provide food but could also enhance psychological well-being, fostering a sense of normalcy amid the stark lunar landscape. The lessons learned from cultivating food on the moon could one day translate to Martian soil and beyond, as we seek to establish life in places where no human has ever set foot. The moon also allows us to experiment with energy production. Harnessing solar power on the lunar surface, where sunlight is almost constant, could lead to breakthroughs in energy storage and distribution. These advancements will be critical as we look to sustain colonies on Mars, where solar energy can be less reliable due to dust storms and the planet's longer days and nights. By mastering the intricacies of lunar energy systems, we set the stage for an energy revolution that stretches across the solar system. Building a lunar colony could ignite a spirit of international collaboration like never before. As countries come together to establish a presence on the moon, they create a shared sense of purpose. This collaborative effort can serve as a model for future endeavors in space, where cooperation will be essential as we navigate the complex ethical and logistical challenges of colonization. By fostering partnerships among nations, we create a foundation for a united approach to space exploration, ensuring that our reach into the cosmos is guided by shared values and mutual respect. Moreover, the moon offers a unique vantage point for astronomical research. From its surface, we can peer deeper into the cosmos with less interference from Earth's atmosphere, unlocking secrets of the universe that have remained hidden. These insights not only expand our understanding of space but also inspire the next generation of scientists and engineers. As we cultivate a lunar colony, we cultivate curiosity itself, a spark that propels humanity forward into the infinite reaches of the universe. The establishment of lunar colonies also invites us to contemplate the social and cultural implications of living beyond Earth. How will we define community in a space where the rules of Earth no longer apply? As small groups of people begin to inhabit the moon, we will explore new forms of governance, collaboration, and creativity. This exploration will shape how humans interact and thrive in environments far removed from our ancestral home, providing valuable insights into what it means to be human in a broader context. As we envision the reality of lunar colonies, we must embrace the challenges ahead. The moon's surface is riddled with perilous conditions, from jagged rocks to deep craters. Each obstacle presents an opportunity for innovation, encouraging us to develop technologies that can withstand the rigors of the lunar environment. The tools and techniques we create to navigate these challenges will pave the way for the construction of habitats on Mars and in the icy realms of the outer solar system. In the larger scope of our cosmic ambitions, lunar colonies stand as a testament to human resilience and ingenuity. They remind us that our capacity for innovation knows no bounds when we venture into the unknown. As each lunar colony becomes a beacon of possibility, we are not just expanding our physical reach. We are expanding our minds and our dreams, envisioning a future where humanity thrives among the stars. With each step we take on the lunar surface, we are not only learning how to survive in a foreign land but also laying the groundwork for our multiplanetary civilization. The moon, our celestial neighbor, serves as a canvas for humanity's greatest aspirations. It is here, in this seemingly desolate landscape, that we will shape our destiny, crafting a future filled with the promise of exploration and the excitement of discovery. As we prepare to build our first bases on the moon, we unlock the doors to an endless frontier, where the possibilities stretch as far as our imaginations can soar. As we journey beyond Mars, the solar system opens up into a realm of wonders and mysteries, where the ice giants, Uranus and Neptune, await our exploration. These colossal planets, shrouded in deep blue hues and swirling atmospheres, are unlike anything we have encountered so far. Imagine venturing into the outer reaches of our solar system, where the landscape is defined by frigid temperatures and winds that howl at unimaginable speeds. It is a place that seems inhospitable at first glance, yet it holds the promise of untold discoveries and possibly even a future where human life could thrive. Uranus, a planet tilted on its side, spins languidly in a unique orientation, while Neptune, its vibrant counterpart, boasts the strongest winds in the solar system. Both giants are enveloped in thick atmospheres rich in hydrogen, helium, and methane, which contribute to their stunning azure colors. As we contemplate colonization, we must consider the challenges posed by their extreme environments. The concept of life on these distant worlds may seem far-fetched, but the exploration of their moons reveals tantalizing clues that could change our understanding of habitability. Take Triton, Neptune's largest moon, a frozen world that is unlike any other. With its geysers spewing nitrogen gas into the thin atmosphere, Triton presents a unique opportunity to study active geological processes. The moon is believed to be a captured Kuiper belt object, offering a glimpse into the early solar system and potentially harboring the building blocks of life. Colonizing Triton could offer humanity a foothold in the icy reaches of space, along with a treasure trove of scientific knowledge. Imagine establishing a research outpost there, powered by geothermal energy from its internal heat, allowing scientists to study the moon's fascinating geology and its potential for life. Uranus also has its share of intriguing moons, like Titania and Oberon, which may hold secrets beneath their icy surfaces. These moons could harbor subsurface oceans, warmed by the planet's gravitational forces. The idea of melting through layers of ice to discover liquid water is not just a dream, it's a tantalizing possibility that could fuel future missions. Such ventures would require advanced technology and innovative approaches, but the potential rewards are immense. They challenge us to think creatively about how we might inhabit these distant worlds and what life could look like in these alien environments. While the ice giants themselves may not provide a suitable habitat for human life, their moons could serve as vital waypoints in our quest for colonization. These celestial bodies could be transformed into launching points for deeper space missions, allowing us to explore the outer solar system and beyond. The prospect of leveraging their resources, water for drinking and fuel, minerals for construction, opens up an array of possibilities. It's a venture that intertwines the spirit of exploration with the practicality of survival. As we look further into the depths of space, we must consider the role of technology in enabling these ambitious plans. Advanced robotics, artificial intelligence, and autonomous systems will be essential for navigating the challenges of colonization. Imagine fleets of drones surveying the icy surfaces of these moons, gathering data and constructing habitats designed to withstand the harsh conditions. The use of AI in analyzing vast amounts of scientific data could lead to breakthroughs in our understanding of these distant worlds and help us identify where to focus our efforts. Even as we dream of colonizing the ice giants, we must grapple with the ethical implications of our endeavors. As stewards of our solar system, we have a responsibility to explore with care and respect. The potential for life, even in the most extreme environments, calls for a thoughtful approach to our exploration. Discussions on planetary protection and the preservation of unique ecosystems will guide our actions as we push the boundaries of human presence in space. The challenges of colonizing the ice giants are formidable, yet the rewards could be transformational. The pursuit of knowledge, the thrill of discovery, and the potential for new frontiers beckon us to venture forth. By embracing the unknown and preparing for the complexities of life beyond Mars, we position ourselves to become a multiplanetary species. Imagine a future where we have established bases on Triton and the icy moons of Uranus, where humanity continuously expands its reach into the cosmos. Each new discovery would not only deepen our understanding of the universe but also of ourselves. The journey to the ice giants is not just about colonization, it is about understanding our place in the cosmos and the interconnectedness of all life. In this age of exploration, we stand on the precipice of a great adventure. The outer solar system, with its ice giants and their mysterious moons, challenges us to think beyond the familiar and embrace the grand possibilities that await. As we forge ahead, let us carry with us the spirit of inquiry and a commitment to exploration that honors the mysteries of the universe. The ice giants call to us, and as we answer that call, we step into a future filled with wonder and discovery, ready to embrace the infinite frontier. As we venture further into the cosmos, our gaze often turns to the myriad of stars that blanket the night sky, each one a potential beacon of hope and mystery. Among these stars lie exoplanets, worlds that orbit distant suns, and represent some of the most tantalizing possibilities for human life beyond our own planet. The search for these celestial neighbors has become one of the most compelling quests in modern astronomy, as we seek to answer the age-old question, are we alone in the universe? With the advent of powerful telescopes and innovative detection methods, astronomers have discovered thousands of exoplanets, some of which reside in the habitable zones of their stars. This is the region where conditions might be just right for liquid water to exist, an essential ingredient for life as we know it. Imagine worlds that may have oceans beneath clouds, landscapes rich with flora, or perhaps even intelligent civilizations gazing back at us. The discovery of such planets not only ignites our imagination but also fuels the hope that life could thrive in habitats beyond Earth. One of the most exciting aspects of exoplanets is their incredible diversity. From gas giants like those in our own solar system to rocky worlds reminiscent of Earth, each exoplanet presents a unique set of conditions and potential. Some orbit close to their stars, experiencing scorching temperatures, while others drift in frigid darkness. These extremes challenge our understanding of habitability, prompting scientists to reconsider what conditions might allow life to flourish. Could there be life on a planet with dense clouds of sulfuric acid? Or within the frozen oceans of a distant ice world? The possibilities stretch the limits of our imagination and require us to broaden our definitions of what constitutes a habitable environment. In recent years, missions like Kepler and TESS have revolutionized our understanding of exoplanets, revealing that they are common throughout the galaxy. This has led to the exciting hypothesis that many stars possess planets capable of sustaining life. The realization that we may not be alone in this vast universe compels us to explore further, not just for the sake of scientific knowledge, but for the potential to find new homes for humanity. As we dream of settling on these distant worlds, it's essential to consider the incredible technological advancements that will be necessary to make this a reality. Spacecraft capable of interstellar travel, life support systems that can sustain human life for extended periods, and technologies that could facilitate the terraforming of alien landscapes will all play crucial roles. For instance, imagine using advanced robotics to modify the atmosphere of a planet, making it breathable, or employing biotechnology to create crops that can thrive in unfamiliar soils. These innovations could turn distant exoplanets into new havens for human life, ensuring the survival of our species in the face of challenges on Earth. Yet, the journey to these exoplanets is not without its challenges. The vast distances involved present significant hurdles. Even with our fastest spacecraft, reaching the nearest star system would take decades, if not centuries. This reality forces us to rethink our approach to space travel. Innovative concepts like generation ships, massive vessels designed to sustain human life over long durations, are being explored, turning the dream of reaching these distant worlds into a tangible goal. Moreover, the ethical implications of colonizing other planets must be carefully considered. As we plan for the future, we must respect any existing ecosystems and potential life forms we may encounter. The pursuit of knowledge and expansion should not come at the expense of other worlds and their unique characteristics. Therefore, our exploration of exoplanets should be guided by principles of stewardship and responsibility, ensuring that we act as caretakers of the cosmic realm. Our thirst for discovery drives us not only to find new worlds but also to understand our place in the universe. The study of exoplanets intersects with the field of astrobiology, which explores the potential for life beyond Earth. By examining the atmospheres and compositions of these distant worlds, we can glean insights into the conditions that foster life. This research not only enhances our understanding of life itself but also informs our exploration of planets within our own solar system, such as Mars and the moons of Jupiter and Saturn. As we look towards the future, the prospect of exoplanets beckons us with the promise of new beginnings. Each newfound world is a reminder that the universe is vast and teeming with possibilities. The knowledge we gain from studying these planets will not only enrich our scientific understanding but also inspire generations to dream big and reach for the stars. In this era of exploration, our quest for exoplanets is more than a scientific endeavor, it is a testament to our enduring spirit, our curiosity, and our desire to connect with the cosmos in profound ways. Every discovery brings us closer to understanding the infinite frontier, and as we continue to unlock the secrets of the universe, we prepare ourselves for a future where humanity may thrive among the stars. The journey has just begun, and the universe awaits, full of wonders yet to be uncovered. As we stand on the brink of this cosmic revolution, the concept of terraforming emerges as a tantalizing possibility, igniting our imagination and challenging our ethics. Terraforming refers to the process of transforming a hostile environment into one that can support human life. Imagine a time when we can breathe the air of Mars, walk through its valleys, and cultivate crops under its sky. The very landscapes of other planets could become as familiar to us as the fields of Earth, but the path to such a reality is paved with both scientific innovation and ethical considerations. At the core of terraforming is a profound understanding of planetary science. For a planet to be made habitable, we must not only consider its atmosphere but also its temperature, water availability, and surface conditions. Mars, our most accessible neighbor, holds immense promise. Its carbon dioxide-rich atmosphere, while inhospitable to humans in its current state, could be transformed through a series of deliberate interventions. By deploying engineered microorganisms that convert carbon dioxide into oxygen, we could gradually thicken the Martian atmosphere, warming the planet and making it more conducive to life. This process would take centuries, perhaps even millennia, but the potential reward is extraordinary: a vibrant world where human beings could flourish. Yet, beyond the scientific marvels lies a tapestry of ethical questions. Who has the right to alter a planet? Mars, while barren in many respects, is still a world that exists independently of us. The ethics of terraforming beckons us to consider the implications of transforming an alien landscape. Are we imposing our will on another world, or are we acting as stewards of the cosmos? The lessons of Earth's environmental challenges should guide our approach to planetary engineering. Just as we grapple with the consequences of climate change and habitat destruction here, we must tread carefully when contemplating the terraforming of other worlds. The notion of terraforming also extends beyond Mars to a broader range of celestial bodies. Consider the moons of Jupiter and Saturn, such as Europa and Enceladus, which harbor vast oceans beneath icy crusts. These intriguing worlds present unique challenges and opportunities. Could we create floating habitats in their atmospheres or even establish bases on their surfaces? The technology needed to terraform these bodies would be revolutionary, requiring advancements in energy generation, resource extraction, and environmental management. The potential to unlock new frontiers of human existence captivates our imagination and pushes us to expand our understanding of what is possible. Yet, as we dream of new worlds, we must also confront the reality that our advancements in terraforming come with significant responsibilities. The very act of transforming an environment raises questions about the preservation of potential extraterrestrial life. If we were to terraform Mars, for example, would we be erasing signs of past microbial life? Current scientific inquiries into astrobiology aim to uncover whether life once thrived on Mars or if it may still exist in hidden niches. Our quest to create habitable worlds must be balanced with a commitment to preserve the traces of life that may reside within. Moreover, the technologies we develop in the pursuit of terraforming could reshape our approach to sustainability on Earth. This vital cross-pollination of ideas may lead to breakthroughs in climate engineering and ecological restoration. By understanding how to manipulate atmospheres and ecosystems on other planets, we may glean insights applicable to Earth's most pressing environmental challenges. The urge to terraform the cosmos can serve as a catalyst for rethinking our relationship with our home planet, inspiring innovative solutions to restore and protect the delicate balance of life here. The dream of making other worlds habitable also compels us to contemplate the social and political ramifications of space colonization. As we envision a multiplanetary society, we must ensure that the benefits of these endeavors are shared equitably. The potential for inequality looms large in the age of space exploration. Will the privilege of terraforming be restricted to wealthy nations or powerful corporations, or can we find ways to ensure that all of humanity has a stake in our shared cosmic future? The ethical framework for terraforming must include considerations of equity and justice, ensuring that we do not replicate the mistakes of our past on a cosmic scale. In the grand tapestry of the universe, the act of terraforming is not merely an engineering challenge, it is a reflection of who we are as a species. Our desire to reach out, to explore, and to connect with the cosmos mirrors our intrinsic need to understand our place in the vastness of space. As we grapple with the science and ethics of terraforming, we embrace the potential to create not just new habitats but new legacies that honor both the marvels of the worlds we seek to reshape and the lessons we gather from our own journey. As we dream of breathing the air on distant planets and cultivating life in alien soils, we must remain vigilant stewards of the cosmos, guided by the knowledge that our actions echo through the fabric of time and space. The infinite frontier beckons us, whispering of possibilities beyond our wildest imaginations. Together, let us navigate these profound challenges, driven by the hope that humanity might one day thrive not only on Earth but across the vast expanse of the universe, crafting a future where we coexist harmoniously with the wonders of the cosmos. As we journey deeper into the infinite frontier, we inevitably confront one of humanity's most tantalizing questions: are we alone in the universe? The field of astrobiology, the study of life in the cosmos, serves as our guide in this exploration, unveiling the conditions that might harbor life beyond our home planet. Imagine the possibility of microbial organisms thriving in the briny plumes of Europa, one of Jupiter's moons, or even the potential for complex ecosystems flourishing on the surface of distant exoplanets. Each discovery reshapes our understanding of life's resilience and adaptability in environments once deemed inhospitable. Astrobiology invites us to expand our definitions of life itself, challenging the notion that existence is confined to the parameters we know. Extremophiles on Earth, organisms that thrive in the most extreme conditions, from the crushing depths of the ocean to the blistering heat of volcanic vents, demonstrate that life can flourish in a myriad of forms. These remarkable beings serve as a testament to the tenacity of life, suggesting that if it can survive in such harsh conditions on our planet, perhaps it can also thrive elsewhere, under the right circumstances. The search for extraterrestrial life is not merely an academic endeavor, it has profound implications for the future of space colonization. If we discover life beyond Earth, it could alter our approach to exploration and settlement. Imagine landing on Mars, not as a barren desert but as a vibrant world filled with microbial life. This would require us to reconsider our methods and ethics regarding how we interact with these ecosystems. Protecting alien life could become as vital as preserving our own, shaping our responsibilities as we expand into the cosmos. Mars, with its similarities to Earth, stands as a focal point in the quest for understanding life beyond our planet. Evidence suggests that liquid water once flowed on its surface, and the search for microbial life in its ancient past drives many missions. What if, beneath its dusty surface, we were to uncover traces of life that existed millions of years ago? This discovery could not only alter our perception of biology but also inform how we establish our presence there. If life once thrived on Mars, our task shifts from mere colonization to stewardship, ensuring we protect remnants of its biological history while forging our path. Beyond Mars, the icy moons of the outer solar system call to us with their hidden oceans and complex chemistry. Europa, for example, hides a vast ocean beneath a thick crust of ice, creating an environment that could potentially harbor life. Similarly, Enceladus, another moon of Saturn, has geysers that eject water vapor into space, hinting at a dynamic and possibly life-supporting environment. The exploration of these celestial bodies could provide pivotal insights into the conditions necessary for life and the diverse forms it might take. The larger universe holds even more possibilities. Exoplanets, those distant worlds orbiting other stars, present exciting prospects for astrobiological research. The discovery of planets within the habitable zones of their stars, where conditions could be just right for liquid water, fuels our imagination. As we learn to detect the chemical signatures of life in their atmospheres, the implications for colonization expand dramatically. Finding biosignatures, such as oxygen or methane in the atmosphere of an exoplanet, could mean we are on the brink of discovering not just life, but potentially intelligent civilizations. Yet, the quest for extraterrestrial life is fraught with ethical considerations. As we venture forth, we must grapple with our responsibilities to protect and preserve whatever forms of life we may encounter. The possibility of contamination either from Earth organisms disrupting alien ecosystems or vice versa poses a significant ethical dilemma. Crafting a framework for exploration that respects both our quest for knowledge and the sanctity of alien life is imperative. Artificial intelligence plays a crucial role in this pursuit. As we develop sophisticated algorithms to analyze vast amounts of data collected from distant worlds, AI becomes our ally. It can help identify patterns that suggest life, analyze environmental conditions, and even assist in the design of habitats that could support human life when we reach these distant locales. The synergy between cutting-edge technology and the principles of astrobiology can propel us into a future where we not only explore but also understand and appreciate the interconnectedness of life in the universe. As we contemplate the vastness of space, we are reminded that the universe is not a sterile void, but a vibrant tapestry woven with the potential for life. Each mission, each probe sent into the depths of space, brings us closer to the realization that we are just one thread in a grand cosmic narrative. The discovery of life beyond Earth would not only revolutionize science but also redefine our place within the universe, inspiring us to consider our responsibilities as interstellar citizens. In envisioning our future as a multiplanetary species, we must embrace the spirit of exploration and discovery that defines humanity. The allure of life beyond our planet is not just a scientific pursuit, it is a call to expand our horizons, deepen our understanding of existence, and cultivate a sense of stewardship towards the cosmos. As we stand at this threshold, a breathtaking vista of possibilities unfolds before us. The infinite frontier awaits, filled with the promise of life, innovation, and the unyielding quest for knowledge. As we venture deeper into the cosmos, the integration of artificial intelligence emerges as a pivotal force in our quest for space colonization. The vastness of space presents not only exciting opportunities but also formidable challenges that demand innovative solutions. Artificial intelligence, with its extraordinary capacity for processing data, learning from experience, and automating complex tasks, holds the key to overcoming the obstacles we will face beyond our home planet. Imagine landing on the surface of Mars, a planet marked by its rugged terrain and extreme weather conditions. In such an environment, AI systems will be indispensable allies. They can analyze data from orbiters and rovers, helping us identify the most suitable locations for human habitats. By assessing geological composition, radiation levels, and atmospheric conditions, AI can guide our decisions with precision, ensuring that we choose the safest and most resource-rich areas for colonization. Once we establish a presence on distant worlds, AI will continue to play a critical role in sustaining human life. Space habitats will require sophisticated environmental controls to regulate temperature, air quality, and water recycling. AI systems will monitor these conditions in real time, making adjustments based on fluctuations in the environment or any unexpected challenges. This adaptive capability will be essential for maintaining the delicate balance needed to support human life in harsh extraterrestrial settings. Moreover, the process of resource utilization will be revolutionized through AI. Mining operations on the Moon or Mars, for example, will rely on autonomous robots guided by intelligent algorithms. These machines will be equipped with the ability to navigate difficult landscapes, identify valuable resources, and extract them efficiently. By optimizing operations, AI can minimize waste and maximize yield, ensuring that every ounce of material is meticulously accounted for, whether it's water ice, minerals, or gases. In the realm of food production, AI's influence will be transformative. Growing food in space presents unique challenges, from limited arable land to fluctuating conditions that can threaten crops. Advanced AI systems can analyze data from sensors monitoring plant health, moisture levels, and nutrient availability. They can predict growth patterns, automate irrigation, and even adjust lighting conditions to enhance crop yields. By utilizing AI-driven agriculture, we can create self-sustaining ecosystems that support human colonists. As we explore the cosmos further, the idea of interplanetary travel becomes increasingly plausible. AI will be vital in navigating these vast distances. Spacecraft equipped with intelligent navigation systems will calculate optimal flight paths, account for gravitational assists, and anticipate potential hazards. Through machine learning, these systems will refine their algorithms, improving efficiency and safety with each mission. The ability to make real-time adjustments during long journeys could be the difference between success and failure in our quest to inhabit other worlds. However, the role of AI in space colonization is not limited to logistics and survival. It extends to the very essence of human experience in these new frontiers. As we spend extended periods away from Earth, maintaining psychological well-being becomes paramount. AI companions, powered by advanced natural language processing and emotional recognition, could provide support and companionship to colonists. These virtual allies would be equipped to engage in meaningful conversations, offer entertainment, and even assist in decision-making, easing the isolation often felt in the vastness of space. While the potential benefits of AI in space colonization are awe-inspiring, they also raise important ethical considerations. As we entrust machines with critical tasks, we must ensure that their design reflects our values and priorities. Transparency in AI decision-making, accountability for actions taken by autonomous systems, and the preservation of human dignity will be vital as we forge ahead. Engaging in discussions about the ethical implications of AI will enable us to create a future that aligns technology with our aspirations for exploration and coexistence. Furthermore, the collaboration between human ingenuity and AI capacity paves the way for unprecedented discoveries. By harnessing the analytical power of AI, we can sift through vast amounts of astronomical data, searching for signs of life beyond our solar system or understanding complex cosmic phenomena. The partnership between human creativity and machine intelligence can drive scientific breakthroughs, enriching our understanding of the universe and our place within it. The role of AI in space colonization also underscores the necessity for international cooperation. As we embark on this monumental journey as a species, sharing knowledge, technology, and resources will be essential. Collaborative efforts in developing AI systems can ensure that they are accessible and beneficial to all, fostering a spirit of unity and shared ambition as we reach for the stars. In the grand tapestry of space exploration, AI stands as a beacon of hope and possibility. It represents our desire to transcend the limitations of our terrestrial existence and embrace the boundless potential that lies beyond. As we build our future on other worlds, the marriage of human vision and artificial intelligence will be crucial in realizing our dreams of becoming a multiplanetary civilization. With each step we take into the infinite frontier, we unveil not just the universe around us but also the limitless capabilities of our own ingenuity, guided by the intelligent systems that will accompany us on this unprecedented journey. Together, we will write the next chapter of human history among the stars. As we venture deeper into the realms of space colonization, one revolutionary concept stands out: the space elevator. Imagine a structure reaching from the surface of our planet all the way into the vastness of outer space. This extraordinary vision, once confined to the pages of science fiction, is increasingly becoming a topic of serious scientific inquiry. A space elevator could redefine the way we access space, drastically reducing the cost and complexity of sending materials, equipment, and even people into orbit and beyond. The design of a space elevator is both simple and astonishing. It consists of a tether anchored to a point on Earth, extending up into geostationary orbit and beyond. At the top, a counterweight hangs in space, maintaining tension that keeps the tether taut. This ingenious arrangement allows vehicles, often referred to as climbers, to ascend and descend the tether using minimal energy, drawing power from laser beams or solar panels. With the ability to transport cargo and passengers efficiently, the space elevator would effectively bridge the gap between our planet and the cosmos, transforming our approach to space travel. This concept is not just a marvel of engineering, it represents a paradigm shift in how we view and utilize space. Currently, launching payloads into orbit requires vast amounts of fuel and energy, making space access expensive and often impractical. A space elevator could reduce the energy needed for these launches by up to 98%. This dramatic cost reduction would open the floodgates for innovation, enabling a new era of exploration and colonization. Imagine the possibilities: the infrastructure required to build a colony on Mars or to establish a base on the Moon could be delivered with unprecedented ease and efficiency. The dream of multiplanetary settlements could become a tangible reality. The construction of a space elevator would also serve as a catalyst for technological advancements. The materials required to build such a structure must be incredibly strong and lightweight. Theoretical discussions have focused on carbon nanotubes and other advanced materials that could withstand the immense forces at work. The development of these materials not only promises to revolutionize the space elevator but could also have broad applications here on Earth, impacting industries from construction to electronics. As we push the boundaries of technology to make the elevator feasible, the innovations we create could improve our daily lives, showcasing the profound interconnectedness of space exploration and terrestrial advancement. However, the journey to establish a space elevator involves challenges that require global cooperation and vision. Building such a structure would demand significant resources, advanced engineering capabilities, and a commitment from nations across the globe. The collaborative spirit that fuels space exploration could be a unifying force, bringing together scientists, engineers, and governments with a shared goal of reaching for the stars. As we embark on this monumental task, we must also consider the environmental impacts and ethical implications of our endeavors. The construction and operation of a space elevator must harmonize with our commitment to protecting our planet, ensuring that our quest for the cosmos does not come at the expense of our home. Beyond its practical implications, a space elevator could ignite public interest and support for space exploration. By making space more accessible, we invite curiosity and creativity to flourish. As more individuals participate in the adventure of exploration, we can cultivate a generation inspired to think beyond the confines of Earth. Education and outreach initiatives could thrive, prompting young minds to dream of careers in science, technology, engineering, and mathematics. With the allure of the stars within reach, the human spirit could soar to new heights. As we envision the future anchored by a space elevator, we must also consider its role in our broader cosmic ambitions. This structure could serve as a launching point for deeper space missions, making it easier to deploy spacecraft destined for Mars, the asteroid belt, or even the icy moons of the outer solar system. The possibilities are virtually limitless. The elevator could facilitate the construction of orbital platforms for research and habitation, paving the way for a sustained presence in space. Imagine thriving communities living and working in low Earth orbit, conducting experiments that unlock the mysteries of the universe, or even reaching out to explore the furthest corners of our solar system. The promise of a space elevator is a testament to human ingenuity, reflecting our relentless drive to explore and understand our universe. As we set our sights beyond the confines of our home planet, we must remember that each step we take into the cosmos is a step toward not just survival but thriving as a species. The pursuit of this ambitious project embodies the spirit of exploration that has defined humanity for millennia. It invokes the same wonder that drove our ancestors to set sail into uncharted waters, pushing the boundaries of their known world. In the grand tapestry of our cosmic future, the space elevator could well be the thread that connects our aspirations with our realities. It holds the potential to transform our societies, economies, and understanding of what it means to be a multi-planetary civilization. As we stand on the brink of this new age of exploration, let us embrace the challenges and opportunities ahead. The infinite frontier awaits, beckoning us to reach for the stars and, in doing so, redefine our place in the universe. As we venture into the cosmos, the excitement of discovery is often accompanied by profound questions about our responsibilities as explorers. The act of colonizing new worlds is not just a technical challenge, it carries with it a weighty moral imperative. What gives us the right to alter landscapes that have evolved over eons? How do we balance our aspirations with the ethical considerations of interplanetary stewardship? These questions are as vast as space itself, demanding thoughtful reflection as we move forward in our quest to become a multiplanetary species. The allure of new frontiers is undeniable. However, as we consider the colonization of planets like Mars or the Moon, we must confront the ethical implications of our actions. Each celestial body we explore has its own unique environment, history, and potentially even its own forms of life. Therefore, the potential for contamination, both biological and environmental, must be at the forefront of our minds. The very act of establishing a human presence on another planet raises the question, are we merely visitors, or do we risk becoming unwelcome invaders? It is essential to acknowledge that the race to establish a human foothold in space is not merely about national pride or technological prowess. It is about understanding and respecting the ecosystems we encounter. For instance, the search for microbial life on Mars or the icy moons of Jupiter leads us to ponder whether our presence might disrupt those fragile environments. The principle of planetary protection emerges here, urging us to tread lightly, ensuring that our explorations do not leave behind a trail of irreversible damage. Moreover, the ethical considerations extend beyond environmental concerns. They encompass the cultural and philosophical dimensions of space exploration. As we seek to establish human settlements on other planets, we must also consider the legacy we leave behind on Earth. Will our ventures into the cosmos reflect our best qualities, our curiosity, our desire to learn, and our commitment to cooperation? Or will they be marred by the same conflicts and inequities that have plagued our history? In envisioning a future where humans inhabit multiple worlds, we must strive to create an inclusive framework that values cooperation over competition. The lessons learned from colonization on Earth should guide us. History has shown us the devastating consequences of exploiting resources without regard to the rights and dignity of others. As we look to the stars, the imperative to foster mutual respect and equitable sharing of resources becomes paramount. This asks of us not only to engage with one another but also to engage with the potential life forms we encounter, should we find them. This brings us to the concept of space diplomacy. Just as nations engage in discussions to resolve conflicts and negotiate treaties on Earth, we must consider how similar frameworks can be applied in space. Cooperation between nations and private entities will be essential in establishing norms and regulations for space exploration. The Outer Space Treaty of 1967 serves as a foundational document, asserting that space is the province of all humankind. Its principles promote peaceful exploration and the responsible use of outer space, but as our ambitions grow, so too must our commitment to ethical exploration. The involvement of private space companies adds another layer of complexity. With the rise of commercial endeavors, the potential for profit can sometimes overshadow ethical considerations. The responsibility lies with both the public and private sectors to forge a path that prioritizes sustainability and ethics. The decisions made today will set the precedent for generations to come. Therefore, establishing clear guidelines and ethical frameworks that govern space exploration is crucial, ensuring that we do not repeat the mistakes of the past. In this burgeoning era of space colonization, the role of education cannot be overstated. Instilling a sense of ethics in future generations of scientists, engineers, and explorers will shape how humanity interacts with the cosmos. Raising awareness about the implications of our actions, fostering critical thinking, and encouraging dialogue around the ethical dimensions of exploration will empower future leaders to make responsible choices on behalf of all humanity. As we consider the unknowns of interplanetary life, we must also grapple with our own humanity. The drive to explore is deeply ingrained in our nature, yet it is tempered by a responsibility to act justly. How we approach this responsibility will define not only our legacy in space but also the ethos of the civilizations we build. Exploring the infinite frontier is a testament to our shared aspirations and dreams. However, as we stretch our reach into the cosmos, we must ensure that our actions echo the values we hold dearly on Earth. The challenge ahead is profound, urging us to balance our ambition with humility, our curiosity with caution. To navigate this uncharted territory ethically is to embrace the full spectrum of what it means to be human, a species capable of wonder and wisdom, ambition, and responsibility. In doing so, we may discover that our journey into the stars is not just about finding new worlds but also about becoming better stewards of our own. As we envision a multiplanetary society, we must consider the rich tapestry of cultures, technologies, and philosophies that will emerge across different worlds. Imagine waking up on Mars, the rusty landscape stretching before you, framed by the towering Olympus Mons and the vast expanse of the Martian sky, where sunsets paint the horizon in shades of crimson. Here, every day would be a blend of adventure and challenge, igniting the human spirit as we learn to adapt to alien environments. What would it mean to build a community on a planet with such stark differences from our own? In this new society, the architecture would reflect not just functionality but also the deep yearning for connection to our earthly roots. Sustainable habitats might mirror the organic shapes of nature, designed to withstand the harsh Martian winds while incorporating advanced technologies that recycle air and water. A fusion of biology and technology could give rise to living structures, using local materials and perhaps even genetically engineered organisms to create homes that breathe and grow alongside their inhabitants. Within this interconnected web of colonies, communication will be paramount. Advanced networks will allow for a seamless exchange of ideas and information, transcending the vast distances between planets. Each settlement, be it a thriving Martian city or a lunar outpost, will contribute unique perspectives, fostering a rich dialogue that enhances our understanding of life beyond Earth. As we navigate day-to-day challenges, the knowledge we share will bind us together, creating a sense of unity and purpose across the cosmos. Education in such a society will evolve to meet the demands of life on different celestial bodies. Learning will not just be about absorbing facts but about hands-on experiences that encourage critical thinking and innovation. Imagine a classroom on Mars, where children explore the geology of the planet through field trips to ancient riverbeds, or a workshop on the Moon, where students design the next generation of space vehicles. The curriculum will blend science with philosophy, art with engineering, nurturing well-rounded individuals who embrace the complexities of life on multiple worlds. As we expand our reach into the solar system, the governance of our new societies will also need to be reimagined. Laws and ethical frameworks must grapple with the realities of life beyond our home planet. Will we establish interplanetary governing bodies that represent the diverse interests of each colony? How will we address conflicts that arise from competing resources or differing cultural values? The principles of democracy may evolve, influenced by the lessons we learn from history on Earth. Perhaps a new model of governance will emerge, one that emphasizes collaboration, fostering a spirit of cooperation driven by our shared responsibility to care for these new homes. Economically, a multiplanetary society will present both challenges and opportunities. Industries focused on space exploration and colonization will likely flourish, creating job opportunities that span the solar system. Imagine asteroid mining ventures extracting vital resources to fuel our expanding frontier. A robust trade network could develop between planets, with goods, ideas, and innovations flowing freely, each world contributing its unique strengths. This interconnected economy will require innovative approaches to currency and trade, as traditional systems may prove inadequate in the vastness of space. Culturally, our experience of art, music, and storytelling will be enriched as we draw inspiration from the diverse environments of different planets. Artists will find new mediums to express their vision, using the unique materials available in space, while musicians will compose symphonies that echo the sounds of alien winds and landscapes. Literature will explore the complexities of identity and belonging in a universe where home is no longer a single planet but a collection of vibrant cultures spread across the stars. Yet, all these advancements must be tempered with an awareness of our responsibilities. As we venture into new realms, we will need to approach the ecosystems we encounter with respect and care. The drive to alter a planet's environment to suit human needs, through terraforming for instance, raises profound ethical questions about our right to change worlds that have existed for eons. In this new society, we will learn to balance our ambitions with stewardship, ensuring that our quest to thrive does not come at the expense of the very worlds we seek to inhabit. Finally, as we gather under the vast canopy of stars, the shared experience of living on multiple planets will forge a new identity for humanity. We will recognize that we are not just Earthlings, but cosmic citizens, bound together by a shared destiny in the universe. This realization will change how we view our place in the cosmos, igniting a sense of responsibility not only for our new homes but for Earth itself. With each leap into the void, we will carry with us the lessons learned from our past, aiming to create a future where harmony and innovation coexist. In this infinite frontier, we stand on the brink of unimaginable possibilities. As we seek to build a society that spans planets, we embrace the duality of our nature, the dreamers and the doers, the explorers and the caretakers. The journey ahead will be complex and fraught with challenges, yet it is a journey worth taking, for it holds the promise of a future that transcends the limitations of our present. Together, we will create a legacy that reflects the best of humanity, one that inspires generations yet to come as we carve out a home among the stars. As we turn our gaze toward the stars, we find ourselves not just in the realm of governments and national agencies, but also in an exciting new era driven by the private sector. The influence of private companies in space exploration has skyrocketed, reshaping the landscape of our celestial ambitions. This shift represents a pivotal evolution in the way we engage with the cosmos, giving rise to innovative solutions and unprecedented opportunities. In recent years, we have witnessed a remarkable surge of entrepreneurial spirit in space, with visionaries and innovators stepping forward to realize dreams that once seemed beyond our reach. Companies like SpaceX, Blue Origin, and Virgin Galactic have captured the public's imagination, pushing the boundaries of technology while significantly reducing the cost of access to space. Their endeavors have illuminated a path toward the stars, demonstrating that the quest for space is no longer solely within the purview of government-funded programs. Instead, it has become a vibrant marketplace ripe with competition and collaboration. These private entities have not only brought new ideas to fruition but have also changed the very fabric of space exploration. With a focus on reusable rockets and rapid development cycles, they are pioneering technologies that allow us to explore further and faster than ever before. SpaceX's Falcon rockets and Starship systems exemplify this shift, emphasizing efficiency and cost-effectiveness, while also laying the groundwork for ambitious missions to the Moon, Mars, and beyond. Meanwhile, Blue Origin's New Shepard is redefining the boundaries of suborbital travel, making space tourism a tangible reality for those who dream of seeing Earth from above. The impact of private industry extends beyond just launching missions, it encompasses the entire ecosystem of space activities. From satellite deployment to lunar landers, the private sector is playing an integral role in building the infrastructure necessary for future colonization efforts. Companies are developing advanced technology for communication, navigation, and data transfer that will form the backbone of our multi-species endeavors across different celestial bodies. The collaboration between government agencies and private firms creates a synergy that accelerates progress, enabling us to harness the strengths of both sectors. One of the most exciting aspects of this private sector involvement is the diversification of investment in space exploration. Traditional funding models reliant on government budgets can be slow-moving and limited. In contrast, private companies are continuously seeking new investment avenues, tapping into public interest and private capital in unprecedented ways. Crowdfunding, venture capital, and public-private partnerships are now common tools that help finance ambitious projects aimed at conquering the cosmos. This democratization of space funding allows for a wider array of ideas and initiatives, from asteroid mining to space habitats, to flourish. It's also essential to recognize how the private sector's agility and innovative spirit can inspire new generations. By making space more accessible, we are igniting the imaginations of young people who once believed that only astronauts and scientists could reach the stars. When companies showcase their achievements, such as successful launches or the first civilian spaceflights, they inspire countless dreamers to consider careers in STEM fields, art, and beyond. The excitement around commercial space travel and exploration creates a cultural phenomenon that resonates far beyond the technical realm, fueling aspirations and igniting creativity. However, as we venture further into this new era, we must also navigate the challenges that accompany increased private sector participation in space. The potential for competition to devolve into conflict is a real concern. As companies vie for dominance, the risk of monopolistic practices and inequitable access to space resources grows. Striking a balance between competition and cooperation will be vital, ensuring that the benefits of exploration and colonization are shared among all of humanity, rather than concentrated in the hands of a few. Moreover, ethical considerations must be at the forefront of our collective consciousness. The prospect of mining asteroids or extracting resources from other celestial bodies raises profound questions about ownership, environmental stewardship, and the rights of future generations. As private enterprises venture into this uncharted territory, we must collectively envision frameworks that protect our shared interests and ensure that exploration does not come at the expense of our values. International collaboration emerges as a key component in addressing these challenges. By fostering cooperative agreements among countries and private companies, we can establish norms and guidelines that govern our actions in space. Treaties that prioritize sustainability and equitable resource distribution will be crucial as we expand our footprint beyond Earth. The narrative of space colonization must transcend nationalistic ambitions, embracing a vision that reflects our shared heritage as Earthlings. In this context, the role of the private sector can be transformative. With entrepreneurial innovation and a willingness to experiment, private companies can lead by example, demonstrating how to balance ambition with responsibility. Their involvement could serve as a catalyst for establishing international partnerships and collaborative frameworks, ultimately guiding humanity toward a future that prioritizes exploration while safeguarding the values we hold dear. As we reflect on the possibilities that lie ahead, the growing influence of private companies in space exploration and colonization efforts fills us with a sense of hope and excitement. Together, we stand at the threshold of a new age, one where the dreams of generations past are within our grasp. With every launch, every innovation, and every step toward the stars, we are not just writing a chapter in the story of human exploration, we are crafting a narrative that has the potential to define our very existence among the cosmos. As we gaze into the vastness of space, the possibility of interstellar travel looms like a shimmering beacon, beckoning us to venture beyond our solar system. It is a challenge that has captured the imagination of countless dreamers and scientists, a tantalizing glimpse of what lies beyond the familiar glow of our sun. The distances involved are staggering, with the closest star system, Alpha Centauri, residing over 4 light-years away, a journey that current technology could span only in tens of thousands of years. Yet, the inexorable march of innovation brings with it the hope that we may one day traverse these cosmic highways at speeds that seem to dance with the fabric of space and time itself. At the heart of this ambition lies the need for revolutionary propulsion systems that can unlock the potential of interstellar travel. Traditional chemical rockets, while reliable for reaching low Earth orbit, simply do not possess the thrust needed for such epic journeys. Instead, scientists are exploring a plethora of advanced technologies that could propel humanity across the stars. Concepts like nuclear thermal propulsion, which harnesses the energy release from nuclear reactions, promise to dramatically reduce travel time to neighboring stars. Imagine a spacecraft equipped with this technology, gliding through the cosmos on a journey that once seemed fantastical, with a travel time of mere decades instead of millennia. Even more enticing is the notion of light sails, propelled by powerful lasers directed from Earth or from orbiting platforms. These sails could harness the pressure of photons, enabling spacecraft to accelerate to a significant fraction of the speed of light. Such an approach offers an elegant solution to the age-old challenge of propulsion, one that relies not on the mass of fuel carried on board but on the infinite energy of light itself. The vision of solar system-faring vessels, propelled by the stars and gliding effortlessly toward interstellar destinations, is not merely a dream of science fiction, it is a glimpse into a future where humanity could become a true interstellar species. Exploring the technologies that could make interstellar travel a reality also leads us to consider the power of fusion energy. By mimicking the processes that occur within the hearts of stars, fusion propulsion systems could provide an unprecedented energy source for spacecraft. The idea of harnessing the same forces that illuminate the cosmos opens the door to spacecraft that could achieve astonishing velocities, making the journey to distant worlds not only feasible but practical. A fleet of fusion-powered vessels could carry humanity to the nearest stars, allowing us to explore, settle, and perhaps even form new civilizations among the stars. But what of the challenges that lie ahead? The vast void between stars is not just empty space, it is a realm full of cosmic hazards, from radiation to micrometeoroids. Any vessel designed for interstellar travel would need to be equipped with advanced shielding technology to protect against these dangers. Furthermore, the isolation of interstellar journeys raises profound questions about human survival and psychology. How will we cope with the extended periods of solitude, the distance from our home planet, and the challenges of living in confined spaces? Research into the psychological and physiological effects of long-duration space travel will be essential as we prepare for the cosmic odyssey ahead. As we contemplate the logistics of interstellar colonization, we must also consider the sheer scale of our ambitions. Establishing self-sustaining colonies on distant exoplanets will require not only advanced technology but also a deep understanding of the environments we wish to inhabit. The discipline of astrobiology will play a pivotal role, guiding us in the search for habitable worlds that may harbor life or the potential for human habitation. Equipped with new tools and techniques, scientists are already identifying exoplanets within the habitable zones of their stars, regions where conditions might be just right for life as we know it. Imagine a future where interstellar travel is no longer the stuff of dreams but a vibrant reality. With each successful mission, each leap into the unknown, we will expand our understanding of the cosmos and our place within it. The dream of becoming a multiplanetary species will evolve into the ambition of becoming an interstellar civilization, one that thrives amid the stars. The path ahead will be fraught with uncertainty and complexity. Ethical considerations will arise as we encounter new worlds, each with its own ecosystems and potential life forms. Navigating these moral landscapes will require a commitment to stewardship and respect for the cosmic neighbors we may discover. The questions we ask now will shape the way we engage with the universe and will define our legacy as explorers. Ultimately, interstellar travel is more than just a technological challenge, it is an invitation to redefine what it means to be human. With every advancement, we peel back the layers of our limitations, expanding the boundaries of our collective imagination. As we stand on the brink of this ultimate frontier, we must remember that our journey into the cosmos is not just about reaching new destinations. It is about the stories we will tell, the connections we will forge, and the future we will create amongst the stars. With each step forward, we are weaving a tapestry that intertwines our fate with the universe, a narrative that promises to resonate for generations to come. As we venture deeper into this cosmic narrative, a crucial element emerges that will empower our colonies and sustain life beyond Earth, the very energy that fuels the stars themselves. Harnessing this celestial energy is not merely a technical challenge, it is a pathway to transforming our presence in space. The universe is alive with energy, from the radiant light of our sun to the nuclear reactions powering distant stars. By understanding and utilizing these powerful sources, we can illuminate not just our colonies, but the future of humanity among the galaxies. Solar energy, the most abundant resource available to us, holds remarkable potential. Imagine vast arrays of solar panels deployed on the lunar surface, capturing sunlight with unparalleled efficiency. The moon, with its long days and minimal atmospheric interference, is an ideal canvas for this technology. As we establish lunar colonies, solar farms could provide a continuous and reliable energy source, powering habitats, research facilities, and mining operations. With advancements in energy storage, we can transform intermittent sunlight into a steady supply of electricity, ensuring that our lunar neighbors thrive even during the long lunar nights. But to truly harness the power of the cosmos, we must look beyond conventional solar solutions. Nuclear fusion, the same process that fuels the sun, offers a tantalizing glimpse into our energy future. If we can replicate the conditions necessary for fusion on Earth, we could unlock a near-limitless supply of energy, providing a sustainable and clean alternative. Fusion reactors would generate energy at an immense scale, using isotopes like deuterium and tritium, which are plentiful in seawater and lithium. This process has the potential to power entire colonies, supporting everything from life support systems to advanced manufacturing and research initiatives. As we explore the possibilities of fusion, we must also consider the technological innovations that will make this dream a reality. Projects like ITER, an international endeavor to create a working fusion reactor, are paving the way. While we are still in the experimental stages, continued investment and collaboration in fusion research could lead to breakthroughs that transform our approach to energy generation. Imagine fusion reactors on Mars, providing the abundant power needed for terraforming efforts, agricultural advancements, and the establishment of a thriving human community. In tandem with fusion, we cannot overlook the role of advanced solar technology, such as space-based solar power. This concept hinges on placing solar panels in orbit, where they can collect sunlight without the hindrance of atmospheric distortion. The energy captured could be converted into microwaves and transmitted back to Earth or to lunar and Martian colonies, providing a consistent energy flow that is unimpeded by day-night cycles or weather conditions. This innovative approach could revolutionize how we think about energy distribution, creating an interconnected web of power that spans not just planets, but potentially entire solar systems. The energy harvested from stars extends beyond just solar and fusion solutions. Asteroids, rich in metals and other resources, present another remarkable opportunity for energy production. These celestial bodies contain isotopes that can be used in nuclear fission reactors or even fusion processes. Envision mining operations on asteroids, where we extract the materials needed for constructing new energy infrastructure while simultaneously generating power. Each asteroid becomes a potential energy hub, fueling our ambitions and extending our reach across the cosmos. As we consider these advanced energy solutions, we are also reminded of the importance of sustainability. The delicate balance we seek in space colonization must factor in environmental stewardship. We must learn from our experiences on Earth, ensuring that our expansion into the cosmos does not come at the expense of ecological health. Embracing renewable energy sources and developing closed-loop life support systems will be vital in creating self-sustaining colonies. Our goal should be to mimic the cycles found in nature, where waste is repurposed and energy is utilized in harmony with our surroundings. However, the transition to these new energy paradigms will not be without challenges. We must confront engineering obstacles, regulatory hurdles, and the ethical implications of harnessing such powerful technologies. As we develop fusion and other energy solutions, it is imperative to engage in open dialogues about their potential consequences. The responsibilities that come with manipulating the fundamental forces of nature weigh heavily on our shoulders. A collaborative approach, involving scientists, ethicists, and policymakers, will be essential in navigating the complexities of energy solutions. In this quest for energy, international collaboration will not only enhance technological advancements but also serve as a unifying force in our exploration of space. By pooling resources and sharing knowledge, we can accelerate our progress and ensure that these innovations benefit all of humanity, not just a select few. The challenges of energy generation in space are daunting, but they also present a remarkable opportunity to come together as a species, working towards a common goal. As we look to the stars, we find not just distant suns, but the promise of a future illuminated by their energy. Fusion reactors, solar panels, and innovative resource management will be the cornerstones of our interstellar ambitions. Each advancement we make brings us closer to a reality where human life flourishes beyond the confines of Earth. The energy of the stars is not merely a resource, it is a beacon, guiding us toward a future filled with unprecedented possibilities, where our colonies are not just surviving, but thriving under the celestial canopy. With every step we take, we edge closer to a time when the energy of the cosmos fuels our dreams, transforming the infinite frontier into our new home. As we contemplate this vast and thrilling vision of our cosmic future, it becomes clear that the very landscape of our solar system is teeming with untapped resources. The asteroids that drift silently through the void are not merely remnants from the formation of our planets, they are treasure troves waiting for us to unlock their secrets. Imagine metallic asteroids, containing precious metals like platinum and gold, floating just beyond Earth's grasp. These celestial bodies hold more wealth than we could ever conceive, waiting to be harvested by future pioneers. The potential for utilizing these cosmic resources offers a path toward sustainability for our burgeoning colonies, allowing us to establish a truly multiplanetary society. Mining asteroids is not merely a fanciful dream. It is grounded in the realm of possibility, fueled by advancements in technology and a growing understanding of our celestial neighbors. The process of extracting materials from these asteroids could provide essential building blocks for construction, fuel for spacecraft, and raw materials for life support systems. Picture a future where our ambitions are no longer tethered to the resources of a single planet, but instead harnessed from the very bodies that orbit the sun alongside us. The implications are staggering, as this paradigm shift could redefine our existence beyond Earth. But how do we begin to tap into this cosmic bounty? The first step lies in the development of spacecraft designed for these missions. Robotic explorers equipped with advanced mining technologies could land on asteroids, survey their composition, and collect samples with precision. These machines would be our eyes and hands in the vastness of space, performing tasks that would be too risky or costly for human astronauts. Utilizing remote technologies, we could extract materials and transport them back, potentially revolutionizing our supply chains. This is not science fiction, it is a glimpse into a future where the cosmos is our quarry. While asteroids often steal the spotlight, we must not overlook the potential of the Moon and Mars as resource-rich environments. The lunar surface is abundant in helium-3, an isotope that could serve as a powerful fuel for fusion energy, an energy source that promises to produce clean, virtually limitless power. Establishing mining operations on the Moon could serve dual purposes, securing energy for lunar colonies and paving the way for more ambitious ventures into the depths of space. Mars, too, presents an array of resources, from iron oxide abundant in its regolith to the potential for extracting water from its polar ice caps. The ability to mine these resources will be crucial for sustaining a human presence on the red planet. Imagine a future where we not only extract water to support life but also convert it into hydrogen and oxygen, creating fuel that can propel us further into the solar system. Each new resource unlocked brings us closer to the dream of self-sufficiency and interplanetary travel. Yet, the challenge of mining the cosmos goes beyond just technology and logistics. It raises important questions about ethics and governance. As we venture into this new realm, how do we ensure that the rights to these resources are justly allocated? Who will regulate the mining activities in space? These are questions we must grapple with as we pave the way for future generations of explorers and settlers. Building a framework for cooperation and governance in space will be vital to prevent conflicts and ensure that the benefits of space resources are shared by all humanity. Looking to the future, we can envision a network of outposts and stations dedicated to mining, processing, and transporting resources across the solar system. These hubs could serve as logistical centers, enabling the flow of materials from the Moon, Mars, and asteroids back to Earth and even further into deep space. Such a system would not only bolster our own infrastructure but also lay the groundwork for a vibrant economy that spans the stars. What about the potential of mining resources from the outer solar system? The icy moons of Jupiter and Saturn, such as Europa and Enceladus, are rich in water and may harbor organic compounds essential for life. These moons could become focal points for future exploration and resource extraction, unlocking even more possibilities for human habitation and scientific discovery. The prospect of harvesting resources from these distant worlds expands our vision of what is achievable, pushing the boundaries of our ambition. As we expand our horizons, it becomes increasingly clear that the universe is a vast reservoir of opportunities. The act of mining the cosmos could ultimately transform our relationship with space itself. No longer seen as a barren void, the universe becomes a canvas for human ingenuity and creativity. Each expedition into space brings with it the potential to discover new materials, new forms of energy, and perhaps even new forms of life. In this grand endeavor, we are not just looking to extract resources, we are engaged in an act of exploration and connection. The cosmos, with all its wonders and mysteries, invites us to collaborate, innovate, and dream. The vision of mining the cosmos is not just about the materials we gather but about the future we build. We stand on the threshold of an era where the infinite frontier becomes a nurturing realm of promise, one that echoes the very essence of human aspiration. As we venture forth, we carry with us the hope and determination to forge a new legacy among the stars, transforming the dreams of today into the realities of tomorrow. As we delve deeper into the vastness of space, a crucial element emerges, one that transcends borders and unites humankind in a common purpose. The importance of international collaboration in our quest for space colonization cannot be overstated. Just as the Earth's atmosphere envelopes us in a protective embrace, our collective efforts can shield and propel us toward the stars. The challenges we face in this uncharted territory are monumental, and it is only through cooperation that we can hope to overcome them. Consider the intricate tapestry of human civilization. Throughout history, we have seen that great accomplishments often arise when diverse cultures and perspectives converge. The construction of the International Space Station serves as a testament to this synergy. Built collaboratively by space agencies from across the globe, this remarkable structure orbits our planet as a beacon of what we can achieve together. It symbolizes the merging of scientific knowledge, engineering prowess, and shared vision. In the vacuum of space, where the very essence of survival hinges on teamwork, humanity has demonstrated that collaboration is not merely advantageous, it is essential. The journey to colonize other celestial bodies will similarly demand a pooling of resources, expertise, and technology. No single nation possesses all the tools or knowledge required to achieve such an ambitious goal. Mars, with its harsh environment and extreme conditions, will require a multidisciplinary approach that draws upon the strengths of various nations. From advanced robotics to deep space communication systems, the innovations needed for successful colonization will arise from the collaborative efforts of scientists, engineers, and dreamers around the world. Imagine a future where researchers in one country develop cutting-edge life support systems, while engineers in another create powerful propulsion technologies. Together, they can pave the way for a sustainable human presence on the red planet. Moreover, as we venture farther into our solar system and beyond, the complexities of space exploration will only increase. The logistics of transporting materials, establishing habitats, and maintaining human health in extraterrestrial environments will require a comprehensive framework of international cooperation. By sharing knowledge, data, and best practices, nations can accelerate the pace of discovery and innovation. This collaboration will not only enhance the efficiency of our efforts but also ensure that we are prepared for the unexpected challenges that await us. In this cosmic endeavor, we must also acknowledge the ethical dimensions of our actions. As we set our sights on colonizing other planets, the interactions we have with our own celestial neighbors must be guided by a sense of responsibility. It is vital that we establish principles that govern our exploration and utilization of space resources, ensuring that we do not repeat the mistakes of our past. By engaging in international discussions and agreements, we can work toward a unified framework that preserves the integrity of other worlds while allowing for sustainable exploration and habitation. Additionally, the role of space diplomacy will become increasingly important as nations navigate their interests and ambitions in space. Just as alliances and treaties have shaped the course of history on Earth, similar agreements will be necessary to manage our presence in the cosmos. From defining territorial claims on the Moon to coordinating joint missions to Mars, fostering a spirit of collaboration will be key to preventing conflicts and ensuring that space remains a realm for peaceful exploration. The advent of private companies in the space sector adds another layer to this narrative. As commercial enterprises push the boundaries of what is possible, their involvement presents both opportunities and challenges. International collaboration can ensure that these private endeavors align with global goals for exploration and colonization. By establishing partnerships between governments and private entities, we can harness the energy and innovation of the private sector while maintaining a cohesive approach toward our shared cosmic aspirations. As we gaze toward distant exoplanets, the potential for colonization expands even further. It is clear that the challenges of reaching these worlds will require a concerted international effort. The distances involved are staggering, with light from some exoplanets taking years to reach us. Pioneering technologies such as advanced propulsion systems and long-duration life support will demand a collaborative spirit that bridges nations and draws upon the brightest minds in science and engineering. In this quest for new worlds, humanity must work together as one, unified by our shared desire to explore the universe. The vision of a multi-planetary society hinges on our ability to cooperate and communicate across cultural and political divides. The infinite frontier is not just a realm of exploration, it is an opportunity to redefine our interconnectedness as a species. By fostering international collaboration, we can build a future where space is a shared legacy, a testament to our collective ingenuity, and a playground for the next generation of explorers. In this shared journey, we must remain vigilant, recognizing that the future we create in the cosmos will reflect the values we hold dear on Earth. The importance of international collaboration is clear, revealing itself as an essential ingredient in the recipe for success as we embark on the immense adventure of space colonization. Together, we can transform the infinite frontier into a realm of possibility, where the wonders of the universe are not only accessible but also a testament to what humanity can achieve when we unite for a common dream. As we stand on the precipice of this extraordinary journey, it's essential to envision what our cosmic future could hold. Imagine a tapestry woven from the threads of innovation, ambition, and collaboration, stretching across the vastness of space. We have already witnessed the birth of groundbreaking technologies that reshape our understanding of the universe and our place within it. Yet, this is just the beginning. The horizon beckons, promising a future where humanity thrives among the stars. Picture a bustling colony on Mars, where families live under domes crafted from advanced materials designed to withstand the harshest conditions. Children play in parks filled with bioluminescent plants, engineered to produce oxygen and provide sustenance. Adults work alongside robots in greenhouses, cultivating crops that could nourish entire communities. This Martian society, grounded in sustainable practices, embodies human ingenuity, merging technology with the natural world to create a balanced ecosystem. Beyond Mars, the Moon serves as both a launchpad and a learning ground. Lunar bases, equipped with laboratories for scientific research and facilities for resource extraction, enable us to unlock the secrets of the solar system. Imagine astronauts exploring the poles of the Moon, not just for ice but for the potential to grow our understanding of lunar geology and its applications. Each step forward on this celestial body could lead to astonishing discoveries about both our Earth and the cosmos beyond. And what if we extend our gaze even further, exploring the icy worlds of Neptune and Uranus? These ice giants may hold untold resources and strange phenomena, waiting for the bold and curious. They could offer insights into the formation of our solar system and the potential for life in extreme environments. As we refine our tools and techniques for exploration, these worlds could transform from distant points of light into destinations filled with opportunity. Venturing into the realm of exoplanets unlocks an entirely new dimension of possibility. With thousands of candidates identified, we are on the brink of discovering Earth-like worlds that may harbor life or conditions suitable for human habitation. Advanced telescopes and satellites, combined with artificial intelligence, allow us to analyze their atmospheres, searching for biosignatures and hints of life. Each flicker of hope ignites our imagination, expanding the narrative of humanity's journey across the cosmos. What would it mean to establish a colony on a distant planet, surrounded by alien landscapes, with the stars shining brightly overhead? In this envisioned future, terraforming becomes a driving force. The science of altering a planet's climate and environment to make it habitable is no longer relegated to the realm of science fiction. Imagine sending fleets of drones to Mars, releasing engineered microbes that begin to transform the atmosphere, creating a slow but steady shift towards a more Earth-like habitat. The dream of turning barren landscapes into thriving ecosystems is within our grasp, a testament to our ability to adapt and innovate. A crucial aspect of this cosmic narrative is the exploration of life beyond Earth. Astrobiology emerges as a pivotal field, merging the quest for life with the search for understanding our own origins. As we investigate the microbial life that may exist in the subsurface oceans of Europa or the thick atmosphere of Venus, we confront profound questions about existence and our place in the universe. Each discovery reshapes our perspective, revealing the interconnectedness of all life. Artificial intelligence stands at the forefront of this cosmic adventure, assisting in tasks from navigation to habitat construction. These intelligence systems analyze data at incredible speeds, helping us make informed decisions about where to settle and how to survive in alien environments. Picture a fleet of autonomous vessels gliding through the cosmos, scouting potential sites for new colonies, all while adapting to the unique challenges each world presents. As we reflect on the ethics of space exploration, we must consider the responsibilities that come with venturing into the universe. Establishing a multiplanetary society necessitates a deep commitment to sustainability, respect for potential extraterrestrial ecosystems, and a sense of stewardship that transcends borders. The lessons we learn from our Earth must guide our actions as we build new homes in the cosmos. The partnership between the public and private sectors accelerates this progress, painting a vibrant picture of collaboration. Space agencies, companies, and researchers worldwide unite in this grand endeavor, pooling resources and knowledge. Together, they forge pathways to the stars, enabling humanity to reach heights we once deemed unattainable. Imagine private colonies flourishing alongside government missions, each contributing to a shared legacy of exploration and discovery. And what of interstellar travel? While it may seem the stuff of dreams, innovative propulsion technologies and the search for wormholes fuel our imaginations. As we harness the energy of the stars and develop means to traverse vast distances, we may find ourselves on the brink of intergalactic exploration, where new civilizations and uncharted realms await. The quest for knowledge and connection drives humanity forward, urging us to embrace the unknown. In this boundless future, the cosmos is not merely a backdrop but a canvas upon which we paint our collective story. The journey into space is not just about survival, it is about thriving, about igniting curiosity and wonder, and about forging a deep connection to the universe. Together, we can transform our dreams into reality, shaping a future that reflects the best of who we are. As we look to the stars, we embrace the infinite frontier, not just as explorers, but as pioneers of a new age, united in our quest for understanding, discovery, and hope. As we stand on the cusp of this remarkable journey, we are reminded that the expedition into the cosmos is not merely about uncharted territories or distant planets. It is a profound exploration of our own potential and a testament to our collective ingenuity. The infinite frontier stretches before us, filled with the tantalizing promise of not just new worlds, but new ways of living, connecting, and flourishing as a species. Each step we take beyond our earthly bounds challenges us to rethink what is possible and reimagine our place in the vast tapestry of the universe. The legacy of our exploration is already rich with triumphs and challenges. From the first tentative steps on the moon to the ambitious probes carrying our curiosity to the edges of our solar system, we have continually pushed the boundaries of knowledge. The endeavor to colonize other planets, particularly Mars and beyond, is a continuation of that legacy. It is not simply an escape from Earth, rather, it represents a profound opportunity to understand our own planet better, to learn how to nurture life in extreme environments, and to create sustainable communities that may one day thrive on alien worlds. The science of colonization, driven by innovation and creativity, is transforming our dreams into actionable plans. From developing habitats that can withstand the harsh conditions of Mars to engineering life support systems that mimic Earth's ecosystems, we are gradually piecing together the puzzle of how humans might live among the stars. Each technological advancement, whether in propulsion systems or in sustainable agriculture, brings us closer to a future where multiple planets could harbor human civilization. However, this journey is not without its hurdles. Life on Mars presents formidable challenges, from the thin atmosphere to the harsh radiation. Yet, with each challenge comes an opportunity for innovation. The solutions we engineer will not only prepare us for life on the red planet, but could also revolutionize life on Earth, providing new tools for sustainability and resilience against climate change. The very act of building a Martian home compels us to confront fundamental questions about our survival, our ethics, and our responsibilities as stewards of the universe. And let us not forget our closest companion in the cosmos, the Moon. Its potential as a springboard for deeper space exploration is enormous. Lunar colonies could serve as a vital blueprint, offering insights into constructing habitats in the harshest environments. As we establish a presence on the Moon, we also lay the groundwork for international cooperation, sharing knowledge and resources, fostering a spirit of unity that transcends terrestrial borders. This sense of collaboration will be instrumental as we collectively embrace the cosmic journey ahead. Beyond Mars, the icy realms of the outer solar system beckon with their own mysteries. The gas giants, with their myriad moons, hold secrets that could redefine our understanding of life itself. Exoplanets, orbiting distant stars, tantalize our imaginations with the possibility of entirely new ecosystems, waiting for us to discover. The prospect of terraforming these worlds ignites wonder and ambition, inviting us to contemplate the ethical dimensions of such endeavors. What does it mean to transform a world? How do we ensure that our actions reflect our highest ideals? As we venture forth into these realms, artificial intelligence will play a pivotal role. From autonomous drones surveying alien landscapes to intelligent systems managing life support in distant colonies, AI promises to be an essential ally in our quest. It will help us navigate the complexities of space colonization, providing insights and efficiencies that could dramatically alter our approach to exploration and habitation. The energy of the stars shines down upon us, and harnessing this energy is crucial for establishing a sustainable presence in space. Solar power, fusion energy, and even the mining of asteroids for resources can provide the fuel for our interstellar aspirations. This pursuit of cosmic resources will not only support our off-world endeavors but also catalyze a new era of innovation and economic opportunity here on Earth. As we reflect on the infinite frontier, we must also consider the ethical dimensions of our explorations. Every mission, every colony, carries a burden of responsibility. Our journey is not just about conquest, it is about respect for the worlds we encounter and the life that may exist within them. The importance of international collaboration cannot be overstated. As we reach for the stars, uniting our efforts will ensure that the exploration of space remains a shared endeavor, governed by principles of peace, sustainability, and mutual benefit. In this grand narrative, the imaginations of today fuel the possibilities of tomorrow. Each child gazing at the night sky, each scientist dreaming of distant worlds, contributes to the tapestry of our cosmic future. Together, we are not just spectators of the universe, we are active participants, co-authors of a narrative that spans the ages. As we conclude this journey through the infinite frontier, let us carry forward a spirit of wonder and ambition. The cosmos is vast and full of mysteries waiting to be unraveled. The future of humanity is intertwined with the stars, and as we venture into this new age of exploration, we do so with the knowledge that the greatest boundaries are those we have yet to cross. So let us embrace the unknown with courage and creativity, ready to transform our dreams into reality and venture boldly into the infinite.